Hello and welcome to another episode of the Melbourne Athletic Development Podcast. As always, this podcast is brought to you by the support of Strength by Numbers. Strength by Numbers have created an integrated clinical and sports performance system. The AXIT system uses force platforms, dynamometry and strain gauges to objectively measure everything from isolated movements to sports performance tasks. The system has greatly enhanced our clinical practice, decision making and objectivity. We are no longer guessing. The greatest thing is its ease of use, both for practitioners and clients. There are no wires, no fixed setup. It is a fully integrated Bluetooth system. If this sounds like something that would enhance your practice, visit strengthbynumbers.com and tell them that Melbourne Athletic Development sent you. Jack.
How are you, John?
Very good. Today, we thought we would start something that we're actually very excited to kind of be doing, which is we've been talking about the concept of bringing in case study discussions. And we think it would be really helpful for our listeners, but I think it's something that is useful for us to have a discussion about because it's something that often people aren't always willing to share, sometimes because you realise that you've done stupid things along the way. But I think it's always nice when you've had, hopefully, a success with someone that you can apply something that you think might be helpful to other people and discuss it and share it.
Yeah, definitely. And I think also to start to apply or thinking about how we apply some of the concepts we've talked about in the real world, because I think that's also a really important.
Yeah, application is important. Yeah. Alrighty. Do you want me to describe it, or do you want to describe?
Well, I think you start because you have much more of a better understanding of this case study than I do.
Okay, so what we had, and if I think back, it's probably in about October last year. So not this year gone, October last year. We had a 20-year-old long jump athlete come and see us with a history of persistent hamstring strains, particularly on one side. And one of them was particularly bad, which he'd done the year before while he was still at school and it was playing football, I believe. There was discussion that it involved the tendon at the biceps femoris down at the sort of musculotendinous junction in the distal portion. But he wasn't necessarily forthcoming with too many details about that because he's a little bit... sometimes like his description of things can be, a little bit different.
Vague.
Yeah, but look, he's really good to work with. So, and we're very, very grateful to him for allowing us to actually discuss this. So thank you to him. The thing that we found with him was he'd had these persistent hamstring strains. His training, to give you some background, his training had been erratic because it was during the period of COVID. And so he'd had some access to his coach and some periods of very limited access. He transitioned from being a hurdler and doing, say, 400-meter hurdles to doing mostly long jump, right? And his understanding of things like sprint mechanics was undeveloped or underdeveloped. And his training history involved some strength training. Some areas were quite good, but some areas were underdeveloped as well. And his exposure to jump training over that period in the lead up to him coming to see us had been patchy. So we've got an interesting picture. We've got someone who's coming to us, and the main report that he was giving is he could run at about 80%, but anytime he tried to do something really intense or something that involved high intensity jumping, he felt like he was going to strain his hamstring.
And I think it's probably just worth mentioning too, like he had some input and rehab protocols between.
And we'll get to that because I think it's a really central part of the journey that we went on with him. So what happened was we started looking into some of the features of what he was doing. And we broke it down into the areas that we've discussed before. We've talked, I think, quite a reasonable length on this podcast about the framework that we use. And the framework that we use is three-pronged. Obviously, it covers what we think are the main drivers for the development of most injuries or the emergent patterns that we see. And the biomechanics, tissue capacities, and the hormetic profile of that person. So if we looked at things like the hormetic profile, as we discussed, his training history had been varied. Some areas had been well developed, others underdeveloped.
Particularly in long jump, considering he had a recent transition.
Yep. Then you've got areas such as his biomechanics, both with running and jumping, and there were some areas there that clearly had been underdeveloped.
Yes.
His understanding of running mechanics and sprinting was reasonable, but not well understood in certain aspects. And in terms of, if we go back to the hormetic profile too, the other thing that his exposure to things like high intensity training, and particularly training that's important for the development of speed power events like sprinting or jumping, was quite minimal.
Yes.
He hadn't done a lot of volume of that. He'd done training around that 80% level. And then if we look at his exposure to tissue capacity training, so things like resistance training, and
that whole force velocity spectrum.
Yeah, flexibility and all the areas across there. Given that he was jumping, his elastic function was reasonable in some aspects, right? And we'll speak about the ones where it wasn't. His strength development was good on a fundamental level. So, he'd been doing things like squatting and then started doing things like power cleans, but he was on the lower end of his force profile, even though he'd been consistent with it and he developed some muscle mass. He's a younger guy. He hadn't done a huge amount of strength training, but his technique was good. It was solid, and he'd done some good foundational work. And then if we look at things like his flexibility, he had some areas that were quite good. So he seems to be really flexible, particularly in the sagittal plane, able to touch his toes, go well over quite easily. But areas such as like his hip internal and external rotation was quite limited, right? Particularly on one side. I don't recall which one, so I apologize to our listeners for that. Most of his hamstring injuries had occurred on the right side. So that's also to give you context with that, because you'll hear as we go forward, there's also another incident that happens that kind of makes us kind of evaluate some other features as well. So what we did is we went through the process of assessing those features that we spoke about, and we started to put together a bit of a picture. And the picture that we got was an interesting picture, actually. It was a little bit different to what I initially expected when I did the assessment with him. So for someone who develops persistent hamstring strain sort of presentations, or even the lack of confidence in their hamstrings, the first thing that as a physio goes through your mind is, okay, maybe they don't have a significant amount of force producing capability in their hamstrings.
And considering too, like he's relatively young as well, hasn't had maybe potentially as much time to actually develop that.
Yeah. So, but I'd known that he had been working closely with a very, very good physio who unfortunately wasn't able to keep seeing him because of a change in work setup, but it wasn't because the person wasn't really good at what they do. So what happened was we used, we promote strength by numbers. The reason is we use that system. We find it really helpful. So we went through a series of tests, and we actually did a series of hamstring bridge tests using the force plates elevated onto a 30 centimeter box, and we resist isometrically by blocking off their hip position and allowing them to put their maximal, voluntary contraction isometrically through their foot.
Yeah. So doing essentially like a single leg bridge maneuver with different knee angles.
Yeah.
Yes.
We do two types of tests, one with the knee angle at 90 degrees, one with the knee angle basically at 0, right? And we try and see what they can do. And the cool thing about the data that we get is it gives us the force tracings, and that allows us to assess really two things. One is how much force can they produce, right? Whether that be in newtons, or our system tends to tell you in kilos, but it's an easy conversion, multiplied by 9.8 to get newtons. And also the rate of force development. So how fast are they actually being able to hit, or get towards their peak force output?
Yep.
So the interesting thing that happened was we put him on here, and actually he tested higher than anyone I'd ever seen at that time. Now, since then I've had people test higher, but he was actually the highest I'd ever seen. And I remember looking at the actual, tablet as I was measuring. I'm going, okay, this is not what I expected. My expectation was that he would have low level of force output in his hamstrings.
You'd even think that just from the standpoint of he's had multiple injuries, he's probably not confident, he has some inhibition, but that actually wasn't the case.
And there was not significant asymmetry between sides. So the fact that he was reporting a lot of right-sided hamstring sort of tentativeness with the tasks or sensory information, I thought, okay, he probably does have some, and if on palpation, he actually did have some change in densification within the tissue in that local area.
Yeah, okay.
So it was like maybe there's going to be force changes, right? Which we do see, right? But interestingly, it was basically symmetrical, and he was producing over 500 newtons of force, which if you look at the data that was produced by the Hamstring Injury Group, he's way above that zone that they suggest is enough strength to be able to be suggestive. Now, obviously those are done in an eccentric fashion, which is different.
Yeah.
But if someone's concentrically being able to produce over 500 newtons,
you
start to expect that they're probably not lacking the force output side of the equation.
Yes.
And given that he was able to do, the straight leg is always lower than the bent leg, but he was able to produce over 400 newtons with the straight leg as well, which, and this is anecdotal, I understand, but empirically we're trying to develop some understanding of these data sets. What we found was that the straight leg seems to be the one that tends to translate more to running or jumping or sprinting type actions in terms of the risk that we tend to see with people who do have, you know, either performance or injury risks with their testing. They tend to produce much lower forces, or there's a big differential between their bent leg and straight leg, and their straight leg numbers are quite low. So
what do you think that is? Do you think it's just got to do with the length of the hamstring musculature and being able to produce high forces?
Yeah, I think it's so much more specific to running.
Yeah.
You know, and if you look at where injuries occur in running, right, and it's up to you whether you buy into one specific methodology, but it tends to happen either just before contact, at contact, or just after contact, right? And that's where the hamstring is in a lengthened position. Your hip is slightly flexed, right, but your knee's starting to become almost extended. It might be slightly flexed, but it's mostly close to extension. So your hamstring length is reasonably long at that point.
Yeah. There's actually a really good paper we discussed this year. I think there's a narrative review with Tony Blazovic talking about that debate, but if people are interested to read more about it.
Look into that paper if you are, but I don't think that that's the most relevant thing. I think the thing that's most...
And besides the point for this conversation.
Well, I think that, the part that's relevant is I think that it happens when your hamstring is under high tension, so mechanical tension, and also at longer lengths.
Yes.
You don't tend to see hamstring strains occur at shorter lengths.
Yeah.
Right? It's not like a high contraction or shortening velocity at a short length causes the issue.
Yes, yeah. And then again, more specifically, being able to produce high forces at a rapid rate. And that was the deficit that was identified in this case.
So we do that and we see, okay, he produces lots of force. The really interesting part was the rate of force development that he could produce, as you just mentioned, was quite low compared to the amount of force that it was creating. And again, what we've tended to find, particularly with isometric muscle testing at least, is that the rate of force development should be in the vicinity of 4 to 5 times the actual force output that you can create. If it doesn't, what ends up happening is it seems like you have a deficit in the ability to tolerate the high velocity movements.
Which in his situation, being a long jumper, is absolutely imperative.
Yeah. So the thing that we found with him is he was only producing about a multiple of two times or a multiple of 2 of his force output. Right. So as measures, as I said, in kilos, he was actually measuring close to 50 kilos for his force output, for the bent leg, for instance, but under 100 kilograms per second, or if you did it into newtons, it would be newtons per second.
Yeah. So like in summary, when we think about the tissue capacity of his hamstring and we assess other areas within the kinetic chain, flexibility within that sagittal plane was actually okay.
Quite good, yep.
Force producing capacity was excellent. Rate of force development, when we think about going to that power spectrum, was quite poor. And then looking at his overall lower limb elastic function was quite good.
Well, okay. Caveat with that. So the other thing that we looked at was his elastic function. So we looked at some different jump tests.
Yeah.
Now, being a long jumper, he had a history of doing bounding, box jumps, plyometrics, including hopping, multiple different hops into the pit, all those kind of things. So he had some history with it. And what was interesting is if you gave him the opportunity to spend time on the ground, so rate of force development tasks that get into that later RFD or rate of force development, things that are probably going to take 250 milliseconds or more, or 200 milliseconds or more, he was quite good, right? And often you see that with bounding as well. People will spend, a quarter of a second on the ground.
Okay.
Whereas with sprinting, it's closer to 100 milliseconds or 0.1 on the ground.
Yeah.
So what we found with him was the slower plyometrics he was excellent at. Vertical jump, even the hop task, so single leg. What he wasn't good at was when we did, when we started to make that window shorter, we did a double leg drop jump to have a look at his at least vertical elastic function and stiffness, and he was quite good. His RSI measure was over 4, right? So it was reasonably good. We have seen, obviously, in very elite jumpers closer to 5, but for a developing jumper, that was quite good. The really interesting thing is when we shifted that to single leg, all of a sudden it became quite poor. And he had an RSI measure under 1.5 for his single leg drop jump, right? And what that tells us is there's too big a discrepancy about what happens when we shorten the time on the ground and when we put him onto one limb.
Yeah, so what we're seeing here specifically is that RFD became particularly prevalent during the single leg elastic function.
Right. So that started to explain why when he started running faster, as you said, faster than 80%, and he's obviously running is unilateral in terms of the contacts,
Of course.
he started to notice that the symptoms came on. So that was really interesting. The last thing that we measured, obviously, and we had a look at, particularly with one of our staff, Lydia, who's trained in strength and conditioning, and obviously she's a weightlifter by background. So she started looking at some of his gym programming, right? And as we discussed, his mechanics were really good. He could squat really nicely, good even positions, all of those kind of things. And his strength was reasonable. I think he was squatting sets of 100 for about 8 reps. Really good form. He was able to do that well. The thing that he wasn't good at was producing power in some of those movements. So when we tested his power output, he was quite low, right? So we often use multiples, say for instance, of watts per kilogram. And if you're doing something like a squat task, something like 50 watts per kilogram is a really nice output. He was closer to 30 or under. So we thought, okay, really interestingly, all the things where he has to go fast, he's not as good at compared to the things where he can spend the time. And that started to build a picture for us. So what we started to do is we started to build some of those things. So once we'd identified these, we thought, okay, we're not going to stop him from training. He needs to be exposed to these things. But we need to be careful about how we expose him to some of that running, how we expose him to some of that jumping, and then we need to build the features around his tissue capacity to be able to support that.
So did you set any particular parameters or constraints about what he needed to do training-wise? On the track, that is, or in the jump pit?
So what we wanted to be able to do is, and a way that often, for people who work with jumpers, they'll know that a lot of jump athletes will spend a fair bit of time doing things of short approaches. And what they do is, say their normal run-up may be 16 strides, for instance, and then what they'll do, often is do, like, say, 6 strides, then 8 or 10, then 12 or 14, and then they'll be doing full run-ups. And they'll be doing, it's like part practice. And it's practicing different speeds and different skills. Now, I'm not going to get into whether that's good, bad, or indifferent. Right? We'll leave that to a coaching discussion for another time. But what we decided was, okay, what we're going to do with you is we're going to develop some of your short approach running and jumping, right, whilst we're building and practicing some of your running mechanics, and whilst we're developing some of the tissue capacities that we think are going to support that before we extend you out. And what we did was we started to increase not only the power production exercises that he was doing in the gym, so we added more Olympic lifting, we added more velocity to a lot of the compound lifts that he did, whether they be deadlifting type tasks, squatting, single leg tasks. And this is all putting this in context, this is all in conjunction with his coach. We have a really good relationship with his coach. So we're working with his coach to decide what exercises he wants to do, and then we're helping the coach kind of develop the way in which they're going to do that. So don't think that we're taking over. We didn't. It was very much, his coach would actually be at most of his physio sessions and most of the strength sessions that he was doing, whether it was with us or often he would do them off-site. but we would do that in collaboration. So what ended up happening was we started developing those features. We were working on running mechanics, and we were working on some of his jumping and building that out. And that kept building on from around November onwards through till the end of the year. And I think we tested him again closer to the end of, closer to Christmas. And we saw his strength numbers stayed relatively similar, but his rate of force development definitely started to increase, which was great. So I think he shifted to about 3 times his maximal force output. Right? His RSI numbers were starting to improve on his single leg, and his power numbers were getting better. Right? And so we thought, great, this is all going well. And what he'd aimed to do was jump early in January. Now, as most people will remember at that time, last Christmas, basically everyone caught COVID, right? They went away, they went to Christmas parties, they went to New Year's Eve parties, and being, at the time he was 19-year-old kid, of course he goes away for the New Year period, and he actually didn't catch COVID himself, but he ended up in an isolation because all of his mates caught COVID. And so basically from the couple of days after New Year's through to, or around New Year's, or just before New Year's through till a week after, I think it was a 7-day isolation that he was in, him and a couple of mates ended up doing, which thankfully none of them actually ended up with COVID, which was good for him and his mates, even though a couple of their other friends did catch it that they were in contact with at a party, I think it was. They got locked inside basically for a week. And he was trying to do some exercises and things, but he's basically locked inside. And there was a competition, I believe it was on the 7th of January. And in his mind, he was hell-bent on doing this competition. So actually it might not have been the 7th, it might have been the 14th. Anyway, something around there. I believe he was basically in lockdown for 7 days. He came out, he did 1 session of jumping and said, yeah, I feel good. Right? And then 3 days later or 2 days later went out and did the competition. Unfortunately, as most people can recognise, that's not the greatest lead up to a comp.
Underloading his system.
Yeah. And then so it's a really big shift in that hormetic kind of stressor, you know, going from complete underloading. Plus, we'll put in the caveat there, he's a 19-year-old kid. He was definitely having some fun over the Christmas and New Year period. You know,
other stresses to his body.
Yeah, he wasn't sleeping much.
Yeah.
He obviously, you know, they were drinking alcohol quite heavily and all of those kind of things. Then he goes into a complete isolation of no training, does 1 session, and then decides to jump. Unfortunately, he actually, his first jump, he jumps a big personal best. It was a really good outcome. He got excited, second jump, really went for it, and actually in the air, as he brought his leg got a bit caught behind him on the right side, and as he tried to swing it through, he actually re-strained his hamstring. So we thought, great, fantastic, right? And obviously he was very disappointed. We were disappointed because we thought he was getting close to being able to compete, and that's why we made this idea of like he's getting ready. Unfortunately, we believed that kind of period of underloading wasn't the greatest idea, and actually the discussion we'd had with him was probably not to compete then because of that isolation, but he really wanted to. Psychologically, he needed that opportunity to feel that he'd made some progress. So we got a little win, which was that he jumped reasonably far, and he thought, okay, this is great. I actually have improved a lot, and there's things there. The downside was he gets that, because of the position of it and because of his previous history with this, we decided to get an MRI. And what we find is there actually is tendon involvement. So straight away that tells us, okay, we need to go a bit slower with this rehab. And that was really, really frustrating for him. And for us, we were quite disappointed, not only for him, but maybe a little bit for ourselves. Maybe we should have been a bit more stern with not starting. Maybe we should have pushed the numbers a bit higher on what we wanted to see with him and his coach before we allowed him to compete. But that's what happened. So what we did was we restarted that process. And really interestingly, what we found, even with the tendon disruption, his force output actually came back reasonably quickly. I believe it was in about 4 weeks. He'd actually gone close to within probably 5% of what his force output was previously. but his rate of force development was still well down on where it was. And that's, I think, the big, and this is where we can really bring in your expertise, Jack. One of the big problems that we see with when there is tendon involvement, what happens to the ability for that complex to create mechanical tension?
Well, I think it highlights a couple of things, because you mentioned that peak force return quite quickly. So I think that highlights that your sensory motor system has such good ability, or the potential, to create alternative patterns to be able to determine where forces are created and distributed throughout that compartment or region. And it's a very common thing that you'll see even with people who have tendon involvement in a soft tissue strain, that peak force is not the limiting factor. That does come back at a reasonable time rate. But when you start to get into those more high velocity contractions, where you're utilising more of the connective tissue system, you start to see a more significant deficit that does take long to come back. So I certainly think, given you everything that you've explained there, it's actually quite a common thing. And I think often too, it's from a clinical perspective, if you don't get an MRI, but you suspect that there is tendon involvement, that will be a key feature that you see at around that, or definitely past that sort of subacute
4
phase.
6 weeks, yeah.
Correct.
And the thing that I think is interesting is, like, what they start reporting to you is interesting, right? Because one of the things they report to you is like, it feels good. I don't have any pain. I feel strong.
They can do all the single leg glute bridges you want. They might be able to do quite high intensity things like Nordic hamstring curls.
Well, they're probably they're definitely doing those things. And I think the thing is, they start feeling like in their dynamic tasks, like whether you're doing drills or even some of their running, they feel like they can go faster because they're not experiencing any pain. But you might be saying to them, okay, you should only be at 70% at the moment, or 75%. And they're saying to you, I can definitely run faster than this. Like, I don't have any problems. But you know that when you actually go and measure those features of the tissue output, it's clearly still a big deficit in things like their rate of force development.
Yes, exactly.
So what happened from there is we kept measuring and going through, and what we did was we built him up across that period of, it was about 12 weeks. And really fortunately, what we were able to do is get him ready for a competition that was coming up closer to the end of the season. And the key features that we tended to be able to work on through that period, and what we found were really important for driving, I think this is probably where we want to go with this, is what do you actually need to do to develop some of these rate of force development features of a tissue? Because I think that's the thing that is slightly different about this case that we had to spend a lot of time on. That's not always the case with some of the athletes or people that you're trying to rehab. So what we did was we started to really outline and put into different, we spoke about it before, exercise classifications of, like, clearly the key competitive exercise is the jumping and or sprinting. Then he's going to have tasks that support that, like jump drills, other running tasks, plyometrics, and then he's going to have the special preparatory type exercises and the features that develop things that support those features above, which are going to be things like his gym, his other plyometric tasks, and then finally he's obviously got his foundational features, which we bring up now. And I want to bring up this because I think it was a really interesting feature that you discussed, and it goes into a discussion on hormetic profile. And we've probably discussed this before, but when we say hormetic profile, what we're basically talking about is someone's ability to deal with stress, right? And clearly, when you say, okay, well, how well can someone deal with stress? That's influenced by so many features.
Well, yeah, and I think something that's been that's quite clear in the literature and is talked about a lot is some of the physical components with regards to training load and training history. But we also need to remember that the musculoskeletal system is not an isolated system. It's interacting with other systems in the body. And so depending on how much stress we're applying to those other systems is going to influence the capacity and also the recoverability of the musculoskeletal system. And that's where we think of that hormetic profile to capture the overall stress capacity of the system or stress tolerance, and what stresses are being applied to give us an indication of how well is this person going to be able to tolerate physical training loads.
And one of the features we found with him that related to this was because of his background of training and sport, when we applied training, and particularly this was evident when we were doing some of the strength and conditioning work with his coach, if you applied the session in a way where he was doing, and even when we were doing some of the rehabilitation, like we put in stuff, you can see it in the background there, the prowler, right? So prowler is like the big pushing sled. When we got him to do things to try and work on some of that, you notice very quickly that his ability to tolerate that high intensity but continuous work was really poor. He was breathing really heavy, he'd start feeling sick in the stomach, and his ability to actually finish out that session with high quality was down. So what we noticed was, okay, he doesn't have a lot of recoverability in his metabolic system, and this seemed to be a key feature with why we think that potentially he'd been developing these injuries under certain conditions.
Yeah, and I think that sort of then goes into thinking about how much training stress can he tolerate, because with his training, it's at such a high intensity. You know, like the reality is where he's going to have the most significance in his ability to develop his performance is working at that 90+%. But if his metabolic capacity is quite low, does he actually have the ability to tolerate those on a regular basis?
And I think that was the thing that we thought, okay, we need to think holistically about this. So what we did was we worked with his coach and we designed some of his rehabilitation and asked his coach to kind of put together stuff that meant that he was getting to this level of fatigue at least at some point through his training week. And the good thing is we found over a period of about 6 weeks that got a lot better. But it also, the thing that it seemed to correspond with was how sore he was pulling up from the mechanical loading that he was doing. So as he tolerated the metabolic stress more, his ability to do things like his rehabilitation, whether they be Nordic hamstring exercise, different types of good mornings, Romanian deadlifts, but even things like his Olympic lifting or squatting, was not creating the same level of discomfort, say DOMS, in the preceding days. Which was really cool because it started to build that picture that we've spoken about before, which is that the metabolic system will actually help support very high levels of mechanical loading.
Yes.
Right? And it's why doing things that have that metabolic conditioning in it is useful for people who do very high intensity tasks, even though it's not that specific biomechanically to the task itself.
Yeah, and again, the mechanism behind that is whenever we apply a mechanical stress, we're creating a response of our immune system, and we're creating a lot of oxidative stress in the process. And that's a normal and necessary element of adaptation. But how quickly that we can deal with those chemical stresses or immunological stresses is a reflection of your overall metabolic system and your buffering capacity and clearance capacity.
So that obviously covers off on some of the hormetic stuff. And what we were also very clear on is when he got to rate of force development around 3 times with his hamstring testing, that clearly probably wasn't enough. So what we decided, we set 4 as the minimum before we allowed him to go to maximal training, and we set 4 times his maximal force output, before he started to get to his ability to compete.
Yes.
And slowly, so what we did was we started to bring in exercises that would challenge that. Now, it's become really popular, obviously, to try and develop, whether it be with hamstrings or other areas of the body, force-producing capabilities. Things like isometric loading has become really popular both in strength and conditioning and in rehabilitation. Obviously, people consistently are doing things through range, right? Both having the eccentric and concentric component. And the other thing that's always been, I think, talked about, particularly since it was developed, especially with, say, like tendon loading in the Alfredson model of eccentric training. it's now been adapted into other areas. And the key one that's very obvious and is clearly evident for this is eccentric loading through Nordic hamstring exercise. With him, we also did tasks like, as I mentioned before, good mornings, back extension variations, and remaining deadlifts that produce a high amount of force at a lengthened position and going through a lengthened position under a high amount of tension. So what we did, though, which I think is the component that's not always talked about, is we started to add loading at higher velocities. And there was two key ways that we did that outside of his sport-specific training in his rehabilitation. One was with the exercises, the way in which the exercises were carried out for the strengthening.
So, in terms of tempo?
Yeah, so the tempo, we really increased the velocity in the tempo that we were using, both for the eccentric portion and the concentric portion. And we went faster with the concentric portion first, and then over time, as he got comfortable with that, we started to go faster with the concentric component, the eccentric component. And then we added in something that I think has become popular, which is something like where it's creating the ability to, stabilize a joint structure really quickly using muscular tendinous and connective tissue structures using like what we call catches. And so what we did over time was we started to use those as a way of getting his muscle, tendon, connective tissue complex to be able to deal with having to create higher and higher levels of contraction at velocity, at a higher velocity, and also with less and less time to actually have to carry that out.
Yeah, so you're effectively trying to bridge that gap between what he needs to be able to do for his sport, but then also creating constraints more specifically to load the affected tissue to be able to tolerate not only the high forces, but also the high velocity requirements of it. And I think that's also something that's, worth highlighting, because you're naturally going to develop those features from being specific with your task, i.e. doing the sport, the actual movement itself. But as you create more constraints, you know that you're going to be able to specifically load that particular region of the body. Because I think one of the things that will naturally occur, and it's probably something that's happened for him, hence why he's had these recurrent injuries, is he's developed these other patterns quite effectively, but still limited, to accommodate for the fact that he's always had this underlying deficit within that region.
And building on that, what we did was we started to use a second form of this kind of rate of force development task, which was not so much strength-based, but was more related to the biomechanics of running, which was using a lot of drilling and altered plyometric type tasks. So what we started to do was bring in a series of different types of run drills that would start to increase the velocity of his limb, going through different ranges and moving at various velocities actually horizontally. So starting with, although his limb velocity might be high, he's turning over at a decent speed, he might only be moving at 2 or 3 meters per second.
Yeah, but again, still bridging that gap of getting to the more sport-specific elements away from the competitive component.
And the key one that I use a lot, and I know that a lot of our team uses, once we feel that someone is starting to require this, is use of what we call like straight leg scissor drills, right? Different, and what that all that is, and for those watching, you can see me moving my fingers, keeping your leg nice and straight and actually trying to flex and extend at the hip and project yourself horizontally.
People, I'm sure, can visualize the idea of like a scissor type action with the legs. Yeah.
The key thing with that, and I put this in because I spend a lot of time explaining to people how to do this, most of the movement needs to come from the hip, right? A lot of people will often point their toe into plantar flexion or their ankle into plantar flexion and then try and push up their calf. You're actually much better off lifting your toe into dorsiflexion and your foot into dorsiflexion and trying to really like drive your heel back towards the ground and project yourself by pushing back to behind you and using your hip and hamstring musculature to be able to project yourself.
Well, about saying you can appreciate then the high amounts of tension that you're applying to the hamstring by doing so.
And obviously there's different ways in which you can overload that. So the speed at which you move at, obviously the range of motion that you go through. So you might only keep it nice and tight. You'll only be flexing and extending your hip, a little bit. Then you can obviously increase that range. And then what we tended to do is increase both the velocity of forward movement, but also the limb velocities and the force that they're applying into the ground. The other variation that I use a lot is actually to do in a slightly bent hip position. So you're sort of semi-sitting.
What's the rationale for that?
It places more tension on the hamstring. So the hamstring's at a slightly disadvantaged but lengthened position, and requires it to be able to create that projection still with high velocity and high force production at the hamstring. And it's a little bit more similar to the feeling for those people who have done fast acceleration. It creates a similar feeling of where your hamstring is when you're in that accelerating position. Where your hip position is slightly more flexed. And your knee and shank is flexed towards the ground.
So again, you're creating more tension by lengthening the posterior chain at the hip.
Yeah. So the thing that we did with that was we tried to progress that by measuring how fast he was moving. Now, if you want to get really in depth with this, you can actually have someone say wear a GPS and be tracking how fast they're moving. You can time them across different distances, and you can see how many contacts they do as well. All right. I wouldn't say that we were that specific with it, but you can be.
Yes.
And I know at a professional level they are doing that kind of thing. They're measuring the number of contacts, the volume of distance, and even the speeds that they hit throughout those. And you can use that as your progressions. You might start at 3 meters per second, 4 meters per second, and you just keep working your way up until you start getting to the point where it's like, okay, they're moving at 6, 7, 8 meters per second.
Yes.
So that developed a lot of the features that we wanted in terms of his rate of force development, and we tried to then, as you said, move them towards more specific tasks. And the cool thing was that we found that we were able to get him to get towards that 4 or 5 times rate of force development whilst not losing any of the strength, because we were still doing some of those maximal output tasks in terms of force. And that was a really clear sign to us that, okay, he's developing the features required of this isolated area and tissue and this, this complex of the hamstring to be able to tolerate these things. And obviously, with anything that requires tendon healing, that the time scale is longer. So we were making sure that we were doing this closer to the point of that 10, 12 weeks.
Yeah. And when did you measure RFD again, looking at hamstring capacity?
We were measuring it probably every 2 to 3 weeks.
Okay.
Right. We weren't doing it every week, but we were measuring probably every 2 to 3 just to kind of get a gauge that what we were doing was actually creating the adaptations that we wanted.
Yes.
Once we started to get closer to those time periods, we started doing more work on his running mechanics. Because this is the other, we spoke about the 3 prongs, hormetic profile. We've just obviously spoken about tissue capacity and some of the interesting relevant things with this patient. The last one was the biomechanics. And there's 2 features with that. One is his running, the other one is his jumping. Now, having a good relationship with his coach, we spoke about his jumping and some of the features that were clear on that. And there were some features, but generally his actual jump technique was reasonably strong. There was a couple of things that he did in his penultimate step, which is on the second to last and the last step, of how he prepared for the board, because you actually need to lower your center of mass in order to be able to create some vertical projection from that, running. You see it even for people who play basketball. Everyone will know you sort of like dip down so that you can jump up to do a layup or dunk or whatever it is. You can't just go from the same height because you haven't created enough of that stretch shorten pattern through your connective tissue.
And like you said, how you need to create more vertical force, because there's so much of it is horizontal. Yeah. Well, at least in terms of your momentum.
Yeah, because the long jump, in many respects, is the person who can create the most optimal vertical projection from as much horizontal speed as they can.
Yeah.
Right? So what we did is I started looking at his running mechanics, and what came out, which was clear, was that he tended to overstride, which meant that he was landing. And when we say overstriding, what we're talking about is someone is landing well ahead of their center of mass upon contact. Right, so the first point when their foot hits the ground, the distance from their center of mass and how far forward that is. Now, that distance is called the front side distance, and you will always have a front side distance. You can't land directly under your hip, right? The reason being is if you did, you would over-rotate, because the moment you land underneath yourself, once the force is applied, you're already...
Center of gravity is keep going forward.
Yeah.
And
so you'll be... And some people do that, and they're those people that you look like they're kind of falling the whole time, right? You can... Like some distance runners will do it. They'll kind of just be falling the whole way. But in sprinting, you can't. You always have to have some frontside distance, because you need time to be able to apply the vertical forces before it becomes horizontal, and you also need the ability to not tumble.
Did this only become more obvious when you started getting into higher speeds as you introduced them?
No, he always tended to run a bit like this. Even when he was jogging, he was sort of overstriding a little bit.
Yeah.
So that was a key feature that we had to work on. And we had been working on a lot of the drilling, so he understood how that was going to change and some of the things that we were talking about when we were in the rehab space and some of the slower running that he was doing. The other key thing that he did that I think is really relevant for the development of hamstring strains is if you don't accelerate well and you don't develop the ability to build speed, there's a common error that occurs, which is that people try and generate speed once they have already reached an upright position. And it's really dangerous, because in that position, particularly your tissue is not in an advantageous position to create horizontal force.
Yeah.
Right?
Just because of the position of your body going from that horizontal to vertical position.
So I think a lot of hamstring strains occur because of ineffective acceleration capability.
People still trying to build speed in the wrong position.
Yeah. And you can see this, and you can try this yourself, right? If you're trying to accelerate, the first thing that anyone does, whether they have knowledge or not, is bring the center of mass lower and tilt their position more horizontally, like their torso, right? Why? Because it's really the way the human body is mostly aligned is to produce vertical forces. Our forces are generally orientated vertically. Now, there obviously are tissues in the body when you look at the different pennation angles that some things don't pull in that direction, right? But typically, if you look at it, most of our tissue is aligned with gravity, right? And that's on purpose, because we evolved to be able to deal with gravity.
Totally. I even think of just like the very basic idea of if you contract your calf, you go up. But the way that we can then utilize that to go forward is change the angle of the shank, of the shin.
Exactly. And so one of the key reasons that I think he was having such issues with his hamstring was he was ineffective with his acceleration, which meant that he was trying to generate more speed once he was already vertical. And the way to do that is to try and use your hamstring kind of like a rake to pull yourself forward. And you're really like raking at the ground.
And do you think that feeds into his overstriding pattern?
Yes.
Then? Yeah.
Right. So I don't think he was overstriding because he thought that was the most effective way to run. He was doing it because it intuitively felt like the way that he could generate more speed.
Yeah.
So what we did was we worked actually on his acceleration mechanics and him understanding how to orientate himself and how to create horizontal forces. And what that did was really changed his upright mechanics quite a bit. And all I asked him to do was just maintain that ability of applying the forces down once he had reached that vertical position with his torso.
Yeah, so it's interesting because you've identified what the problem was, but part of it is going, well, why is he doing that? Because you could have worked all day going, no, I want you to go strike a bit more towards your base of support. But as soon as you change his acceleration mechanics, you start, his acceleration capacity.
It didn't completely, we had to instruct him and create opportunities or, constraints-based model for him to understand once he was up, he couldn't then revert back to that overstriding because that was in his patterning.
Yeah.
But it was something that we had to work on.
And I think it just highlights in then too, that complexity of the cause effect, of why you're actually seeing that outcome. And more often than not, there's multiple elements involved.
So what that allowed us to do, and the really cool thing was, it did take us 3 or 4 months to kind of build these things. But the cool thing was he was effective in coming back and completing a number of competitions after about 3.5 months, where he was able to do full competition, all 6 jumps. He did that multiple times across the next few weeks. And it allowed us to actually evaluate and say, okay, this was a really interesting process for us. And it gave us a lot of information. It's kind of one of the reasons we're sharing, because we think it's a really interesting case of how we had to navigate this problem. And And the cool thing is it's been really effective in him being able to continue on, and he's back competing even now for this next season. And I've still been working with him more on the running side of things, so he comes along to some of the running sessions that we do to work on his running mechanics. Yeah. And he's not 100% there, but he's getting better and better and better. And he competed just this Thursday gone. Again, was able to compete and do all of his jumps, and I think he got all 6 jumps in. Jumped over 7 meters again, which is great. And that was his first competition of the season. So we've been able to use this as an opportunity to explore all of those different areas that we think are important. And we found it a really interesting process.
Yeah. I think it also just highlights too, we've talked about this idea of complexity and this idea of setting up safe to fail experiments. And this was really a process of setting up, safe to fail experiments in parallel and sequentially, because we started to see the evolution of him require different changes or different focuses at different points in time as well. I think it's a really good example of, here's a situation where there are actually multiple modulators involved, and not necessarily the ones you always fall back to of his strength's going to be down because he's had multiple hamstring strains in this example.
Well, I think that's one of the things that we found really useful, and I'm interested to hear your take on this, because one of the things that having objective instruments, it takes away a lot of that bias.
Look, it seems like the most obvious thing to say, but if you don't test it, you don't know.
Yeah.
And I think, particularly too, it's one of the things that's been so advantageous for us is the development of technology and its accessibility allows you to be much more nuanced, or I guess broad, in being able to assess so many different physical parameters.
And that, now the cool thing is it is at a point where it's accessible. There's lots of different systems that work. Obviously, we use the strength by numbers system, the AXIT system, but there's others, and they've all got their benefits and, their detriments, and they're all getting better as time's going on. We do recommend this system, and, obviously they've supported us. So, if it's something you're interested, contact them and support them. As we say at the start, tell them that we sent you. Hopefully they can look after you. But it's not the only system. There's lots of other great ones, and even for the people that are not, at the point where they can invest to that level, there's lots of applications that are available. And we still use some of them as well. We've spoken at different times about, the whole my jump, my sprint, my run, kind of realm that was developed by Carlos Belisabri, and the whole suite I think you can buy for about $20 on the Apple store. Well,
and look, I mean, we're I think different to most clinics in terms of the parameters in that terms of we work in, and I think more importantly, we talk about in this situation a high level athlete. We use all this equipment for every patient that comes in, and we see certainly people from the general population as well.
And I think that's the key thing, this is no different to the 70-year-old female that presents with, painful gluteal tendinopathy.
Completely.
We're using this equipment to get an idea of, okay, what is their force output and rate of force development for their external rotators?
Yeah, and
in their hip, and if it is down, then we need to work on that.
I'm sure, when we do further case studies, we'll talk about different population groups to see that, we really apply the same principles across essentially all population groups.
I think that probably covers off on everything. We hope that you've enjoyed this first case study. If you have questions about it, feel free to get in contact with us. We're always really interested to talk to other clinicians. And as always, make sure that you like and subscribe and share this podcast with other people. Thank you very much.
Thank you, John.